Alright folks, we're back. So you're asked to find the equation of tangent to the curve y equals cos x minus sine x at a point x equals pi over 4. First thing I recommend you do, guys, is to find the actual point at x equals pi over 4. The point turns out to be pi over 4 and 0. This is worth a mark here, folks. The reason why is you found the point. And when you plug it in, this is a special angle. Cosine of pi over 4 minus sine pi over 4 is the same value, so that when you subtract them, you get 0. Now, let's find the derivative. The derivative is equal to negative sine x minus cos x. Now, at x equals pi over 4, now remember when you take the derivative and you need to find the equation of tangent, you don't have to worry about simplifying the expression. Automatically plug in the point, the value of x, such that you get the y prime is equal to negative root 2. Why is that the case? Let's look backwards. Okay, and we'll see why that's the case. That's the case because when you plug in pi over 4, you get negative pi over 2 minus pi over 2. So you get negative 2 pi, sorry, not pi over 2, sorry, negative 1 over root 2 minus 1 over root 2. So that will give us negative 2 over root 2. When you simplify that, you will get negative root 2. We plug that into the equation, and the point, the slope and the point, and we get this as the equation. This will be the final result. You don't need to expand this because it just becomes uglier very quickly. This is good enough for an answer. All right, next one. Example number 4. Determine the extrema on f at x is equal to sine squared x on the interval from 0 to 2 pi. Well, to determine extrema values, you need to set the derivative equal to 0. We do that, and we find out, now remember that sine squared x is actually sine x all squared. So we can find the derivative of that, which will be 2 sine x cos x. Automatically, you should recognize that 2 sine x cos x is actually sine of the double angle. So that we have sine 2x. Sine 2x, sine 2x is equal to 0. That means if we look at the sine function, let's look at that here. Sine function, reminder again, looks like this. So 2x is equal to 0, pi, 2 pi, and we need to keep going because we have a specific interval, so that when we divide by 2, it still remains within the interval, which will be 3 pi and 4 pi. Divide by 2, you get 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, let's say you didn't notice the sine 2x cos x. Sorry, 2 sine x cos x was sine 2x. Well, you would then say sine x is equal to 0 and cos x equals 0. And guess what, folks? When you draw out those, you'll end up with the same values that we found in blue. Because sine x is equal to 0 on the interval 0, pi, and 2 pi. If you look carefully, 0, pi, and 2 pi are found in blue. Cos x is equal to 0 on the intervals at the points pi over 2 and 3 pi over 2. Well, folks, those values are also in blue. So whether you did them separately, or whether you did this line separately and found this in purple, or if you simplified this and made this, you get these values. Notice that all these values are the same as all these values, so you will get the same answer whether you noticed it or not. The in this case, it was the DAF rule that we use, double angle formula. Double angle formula allows us to simplify the expression faster, but some of you may not have seen it, and that's okay. All right, that's the end of this video. We'll see you in the next one. Take care. Have a numerical night.